Okay, welcome everyone. My name is Bogumił Kamiński, and now we will go to the third part of the tutorial on working with text files with data frames, and we will discuss working with text files. So I switch to the third notebook in our material. And first, let me note that we will use a CSV package to read in and write CSV files. So first I load the packages. Next I download the file from the internet that I will want to use, and it is done using a download function, and the name of the file that I will want to use is auto.txt. So if I run this command, the file is downloaded from the internet to my current working directory with the name auto.txt. So let us check that the file was correctly downloaded. I do this using the readlines function, and I can see that this file has the following structure. So first, its data is organized in columns. The columns are mostly separated with spaces, but usually with more than one space. But the last column here, as you can see, is not separated by a space but by a tab, which is a problem. The second thing is that I note that in some columns there is an NA value, which means that this is a missing value and we should handle it appropriately. So in summary, we have a case of a file, and actually it is a typical situation that is not very clean. So before reading it, we should clean it a bit in order to make it possible to be read in by CSV package. So first, let us solve the problem of tabs. So I will solve this problem, but by reading in the whole file as a string using the read function here, and then I replace in this string all the tabs that it contains by spaces using the replace function. So let me run it. So this is now a string with no tabs, and I have checked before that this file does not contain tabs anywhere except this separator of the last column. So now, if I have a string without tabs, I have a problem. I want normally CSV package reads data from files, but now I have a string from which I want to read in the data. The trick to handle it is to wrap this string in an IO buffer, and this creates me an in-memory IO stream that CSV file function can easily read. So I create this IO buffer, and now I can read in the file into a data frame. So first let us read in the file. So this is given here, and now let me discuss how do we do this. So first we use a CSV file function. I pass it the IO buffer. I say that my delimiter is space here. I say that I want to ignore repeated spaces, which means that I know that there are several consecutive spaces in my file, but actually they should not be treated as separating columns that are empty. Simply they should be treated as one separator. So this is what ignore repeated option means. Then, because my dataset has no header, by passing a header keyword argument, I set a header for this data set. And finally, missing string tells CSV file what is the encoding of missing data in my file. And after I run this CSV file command, I pass its result using the pipe operator to data frame. So just to explain to you, if you have never used this pipe, what the pipe does, well, this is pretty easy. For example, if I wanted to calculate a sine of 1.2, this is calculated this way, but I can equally well write it like this. So it means that I pass a value 1.2 to the sign function. So this is what exactly happens here. I pass the value that CSV file returns to a data frame constructor. So in consequence, I get a data frame. And here is this data frame. And this data frame has several important features. First of all, we can see that it contains missing values. And the missing values are typeset in italics so that you can easily distinguish them from other types of values. So for example, you know that this is not a string that just contains missing as text. Also, you can see here a question mark. A question mark indicates columns which contain missing values. So we see that horsepower column also contains a missing value somewhere, although we do not see it yet. Moreover, you can see here that the last column name, here we gave this name here, was not printed, and this is what Julia tells me, that the data frame has omitted printing of one column. This is due to the fact that by default only 80 columns are printed in Jupyter Notebook, but it is easy to change. So for example, change using the nth dictionary. I can change the number of columns and lines that are printed. I say, okay, print me 200 characters in width and print me 15 lines of output. So after changing this, now if I get the contents of df1, I can see that all its columns were printed, and because I changed the lines to 15, I see I get only 15 rows printed, although previously it was 30. Okay, now there is another way to read in this file. This other way would be to let data frames automatically detect the separator in this file, and this is what I do here. And actually now we can see that data frames has detected only 2 columns. Why? Because the only consistent separator in the original file was a tab, which was exactly in one place everywhere. So auto detection algorithm, which is inbuilt into CSV file function, detected that that the tab is the proper way to split it. But unfortunately now we can see that the metrics column, so the first column contains numbers, just strings that were originally everything in each line before the tab. So it is easy to change it, because we can take out the metrics column from our data frame and split it. So now in this operation I take out metrics column from a data frame and then split it using the split function. I broadcast this split function to split every element in the dfrow.matrix column of our dfrow data frame. And I can see that now I get a vector that contains the splitted strings. Now the question is, how can we recreate the columns of a data frame using this str matrix variable? Well, we can do this using a push function that we will use shortly. But first let us just prepare a data frame that is empty. What I mean by empty, it means that is filled with, we say that every column should be float 64, and we give column names for those columns here. So in this way I have created a data frame that has now 0 rows and 8 columns, and they all are float 64. So now we remember that 2 of our columns contain NAs, so missing values. So actually we have to make data frame df1_2 aware of this, and we use allow missing function bank, which means that we will update this data frame in place, and we want to allow mpg and horsepower columns to allow for missing values, because those were exactly the columns that we know that can contain missings. So now, after allowing missings in those 2 columns, we can very easily populate our data frame using a push function, which just adds 1 row to our data frame. So how does it work? Well, the only thing that we have to take care of is to check if the value is an A. If it's an A, then we say it's missing, otherwise we parse the string as float. So each of those arrays here gets converted first to a vector that can contain floats or missings if NA is encountered, and then it's pushed to our data frame as the last row. So let us run it. Yeah, it's pretty quick. And now we can see that we have our data frame already populated. The only problem is that our data frame does not have a name column, but we can easily add this name column by using just set property. So I say that the property name in my new data frame should be the same as the name column in my original data frame df row that we had here. So this is a way to easily add a new column to a data frame. I just say name of the data frame dot name of the new column, and then I pass a new name to it. So let us run this command, and then let's check what is the contents of our data frame, and we can see that it has this name column added. So one thing to be wary of, this is something we already have talked about, but this is really important, so let me stress it. Now df row and df1_2 column names in both of those data frames are shared, so they are exactly the same object. Why? Because as we have discussed earlier, using get property does not copy. So actually there are 3 ways how you can make a copy in order to avoid aliasing of the columns. So either on the right hand side you use a column, on left hand side you use a column, or you use a column on both sides, but of course this is wasteful because now you make a copy twice. Finally, now as I said, there is yet another option how to do this. You could simply write copy here, and you would get also the result that the column would be copied. But let us move forward. What I want to stress is that when you work with data frames, always make sure if you know if different data frames share the same columns as aliases or not. and most of the operations in data frames makes sure that this is not the case, so no sharing is done, but actually this get property operator for speed purposes does column sharing, so you should be sure that you remember to take care of it. So now let us check if our original data frame read using the first method is the same as the data frame we have just created, and we can check it using isEqual function. So those data frames are equal. Why do we need to use isEqual? Well, we have to use isEqual because if we use normal equality, we would get missing, because our data frame contains missing values, and normal equality using two equality sign uses three valued logic, and if anything is missing, then it returns missing. So that's why if your data frame may contain missing values, usually you want to use isEqual to check for data frame equality. But this is the same as in Julia base. So now let us show how we can count how many missing values we actually have in our data frame. We can do this in several ways. So first we use each call function, which will iterate columns of our data frame, and for each column we count missing values in this column and then calculate the sum of it, which is 14. The second option, which is a bit shorter to write but less efficient because it does a conversion from a data frame to a matrix, is just convert a data frame to a matrix and count missing values in this matrix, which is 14. Finally, there is a convenient map calls function, which applies some function to all columns of the data frame. And now we do not calculate the sum of all missing values, but we will get an information how many missing values are in consecutive columns of the data frame. So we can see that MPG column has 8 missing values and horsepower column has 6 missing values. So now the question is, normally if you work with data, you do not like to have missing values. So let us first find out which columns contain missing values, and you can do this using the filter function. So I pass it a data frame, and here I pass it a predicate that will be given each row of a data frame, and I simply check if any of the elements in the row of the data frame is missing. So if I run it, I get only rows that contain missing values, and I get 14 such rows as expected. So another thing that is worth to learn is how you can transform columns of the data frame. So for example, we can see here that in the name column of the data frame, the first word is always a brand of the car. So let's create a brand column exactly as we discussed earlier, but then we simply take a name column from the data frame, split it as we have discussed, and take the first element from what is splitted, which is a brand name. To make sure that we understand what is going on here, let us maybe see what would split produce without taking first of it. So we can see that we have vectors of splitted elements, and that's why we use first function, of course broadcasted, because we have dot here, to get a first element of each of those arrays. So now let us have a look at the data frame after adding a brand sorry, let's add this brand after adding a brand column, and we have it here. So because as I have said, we do not like to have missings in our data frame, so by running a drop missing function, it will remove all the rows that contain missing values from our data frame. So now the data frame df2 will contain only rows that do not contain any missing values. Now let us, for example, answer a question: what are the cars that are given in our file that are of SAP brand? So there are two ways to do this. Either you can use indexing, like in array indexing. So here I select all the rows that where brand is exactly SAP, and I select all the columns. So I run it like this here, and we can see that there are 4 rows that are SAP. We can also use a filter operation here. So I run this filter operation, and I get the same list of rows. What is important is to understand this kind of syntax, because it will be popular in many places in our tutorial. So as opposed to the earlier filter operation, where we passed the whole row of a data frame to a function, I can also specify which columns should be passed to a filter function. So in this case, I only want to pass a brand column to filter, and then it simply says, okay, this brand should be equal to SAP. So here you have an explanation how it can be understood. But of course, if we didn't like this syntax, we can pass the whole row to filter function like here, and now we simply say in each row the brand should be SAP, and I get exactly the same thing. So to finalize the tutorial, let's write this auto2 CSV file to a disk using CSV write function like this. Let us make sure that it has been written correctly using readlines, so we can see now that the delimiter is comma and everything, and we have the names of columns in the first row. So we are ready to move forward to the analysis of this data frame, which we will do in part 4 of the tutorial.